I have four numbers written in standard notation. Standard notation means the number is very long, like standard notation like 41, 62, 35.5. They are standard notation. So that is how you write a number normally. But in this video, do you see that these four numbers, they are pretty long, right? So for example, can you read the first numbers to me? You might be counting. All right, we have 30. Oh, by the way, when you write a number, a long number, you put a comma between every three digits. You might be counting the zero and say, this is like 9 millions, 98 millions, or something like that. Don't worry about how you read it. So what we are trying to do right now is, okay, take a look. So we have 9874 followed by 60. That's all you have to know. We have 9874 followed by 60. So the way we do this is, first of all, I need to point out the first number in my scientific notation, which is, this number must be 9.874. Is there another option? Can that be a 98.74? No. How about 987.4? No. How about 9,874? No. This number must be between 1 and 10. It can be 1, okay, including 1, between 1 and 10. Okay, so 9.874 is the only option. And then we multiply 10 raised to a exponent. So what exponent? So suppose that we have 9.874. So the decimal point is like right here, right? Let me use a highlighter instead. So the decimal point is right here. Okay, and then we go 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we did 9 steps. 9 steps. So from 9.874 to a bigger number, you have to use a positive exponent, 10 raised to the 9 power. So that means this is a positive 9. That means you are holding this decimal point and you are moving this decimal point 9 steps to the right. If you put a negative 9, that means you are making this number smaller. You are taking this decimal and then you move it 9 steps to the left if you are using negative exponent. All right, next one, negative 0 point, how many 0? 4 0, and then 2007. All right, so let's do the writing. So we have 2. Forgot the negative, right? So negative 2.007. And then you are going to ask me, hey, this is not between negative 1 and 10. So what you have to do is you disregard the negative value. 2.007 is between 1 and 10, of course, including 1. It cannot be 20.7. It cannot be 200.7. It cannot be 0.2007. Okay, so this is the only option between 1 and 10. And then multiply 10 to the what power? All right, so this time we are doing this. Let's pick a different color. So 2.007, right? So right here. So that will be 1, 2, 3, 4, 5. So this is a 5 steps. So 5 steps. So since we are going to the left, we are making the 2.007 smaller, right? In order to make that many zeros. So since we are moving the decimal point to the left, and then this will be negative 5 power. So that is the same thing as negative 2.007 negative exponent. That is 10 raised to the 5th power, which is negative 2.007 divided by 1 followed by 50. That means you are moving the decimal 5 steps to the left. But of course, you do not write this on your paper at all. Whatever shows up right here, that is the answer, right? Okay, next problem. You know what? Can I do this? Can I just move this down a little bit more so I can give myself a little more space? All right, the next problem, we have negative 18 followed by many zeros. Okay. What is the first step? The first step is I put the negative, disregard the negative. 1.8 is between 1 and 10, not 18, not 0.18. This is between 1 and 10, 1.8, and then multiply 10 to the what power, and then you have to count the zeros, right? So 1.8, the decimal point is right here. All right, 1.8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this one is 12 steps. 12 steps. So 12 steps, then this is raised to the 12 power. So cover up the negative, you cover up this 1.8 times a very large value. That means you are taking 1.8, you move the decimal point 12 steps to the right. All right, last one. Last one, we have to start with 1.20, right? So this one, we can start with 1.20, 1.02. Should I keep the last zero? So that one depends, because if you don't write this zero, that doesn't change anything. Then you have to read the problem. Do they want 2 decimal places or 3 decimal places? So if they want 3 decimal places, then you have to add a 0. 3 decimal places means you are keeping 3 digits on the right hand side of the decimal point. 2 decimal place means you are keeping 2 digits on the right hand side of the decimal. And then times 10 to the what power? And then we have to count the zeros. All right, so count the zeros. So 1.02, the decimal point is right here. We are moving to the left. 1, 2, 3, 4, 5, 6, 7. So this is 7 steps. And then that will be a negative 7, because you have 1.020 over 10 to the 7th power, which is 1.020 divided by 1 followed by 7 0. 1, 2, 3, 4, 5, 6, 7, in order to make the 1.2 smaller. All right, so that is how you convert from a standard notation, which is a very long value, to a scientific notation. All right, I will see you all in the next video.